I'd now like to work through a couple of examples with simplifying surds. If we look at the first one, we've got two surds connected by a multiply at the top and two surds that are connected by a subtraction on the bottom. Now on the top we call that the numerator, and on the bottom we call that the denominator. So I think as a strategy, as an overall method to keep in mind, we'll try and simplify the top first and then simplify the bottom and then see what becomes of that. So when we're multiplying surds, we simply multiply the numbers together. So 2 times 3 is 6. We write the surd, or the radical sign, and then the surd part is 5 times 10, which is 50, all over. Now this is not multiplying, so we can only add and subtract like surds, so we probably need to play around with the root 8 and see if we can get it into a root 2. So we've got the 5 root 2 minus, now root 8, biggest square number that goes into 8 is 4. So don't forget, when we've got the two radical signs joined together, that's just like the same as square root of 8, but we've split it into the two factors 4 and 2, and we do that because we know that's a square number and we can get the square root of 4 as 2. So let's just have a look at what we can do on the top. Once again, we can simplify root 50. A square number that'll go into 50 is 25, so that's root 25 root 2. 25 times 2 is 50. And then over, we've got to just leave the first one by itself, and then minus, now root 4 is 2 root 2. Just a little thing when you're setting out your solutions to questions and that, you should try and keep equals under equals as you go down the page. It's just a little thing to keep in mind, a little guide to keeping your work neat and tidy. So square root of 25 is 5, and that's why we picked the square number. And 6 times 5 is 30. And 5 root 2 minus 2 root 2 is 3 root 2. Now we look for things that will cancel. Root 2 goes into itself once. 3 into 3 goes once, 3 into 30 goes 10. We multiply out the numbers that aren't cancelled. 10 times 1 is 10. 1 times 1 is 1. And that is just simply the number 10. Second one, we've got 3 surds connected by a minus and a multiply. We go back, order of operations. There's no brackets, there's no indexes, there is division and multiplication, so we're going to do that part of it first. So we got 25 root 6 minus, now we're going to do the multiplication. We multiply the two numbers at the front, 3 2s is 6. And then we can put that all underneath the same one. 12 times 8. 25 root 6 minus 6 times the square root of 8 12s and 96. We can only add and subtract like surds. This isn't like at the moment because we've got root 6 and root 96, so we look to see if we can simplify root 96. So we've got 25 root 6 minus 6. The biggest square number that goes into 96. Well, 4 will go into it, but I think we can go bigger than 4. 16 will go into 96. So it'll be root 16, and we say, well, okay, what are we going to multiply 16 by to get 96? And that'll be 6. 25 root 6 minus 6 times, now that's equal to 4. Square root of 16 is 4. 6 4s are 24. If you've got 25 of something and you take away 24 of something, you get one of those somethings, and those somethings are root 6s. We tend not to put the 1 at the front there, and we just write it as root 6. Okay, so there we go. We've got 2 examples there, a little bit more complicated. Working with surds, don't forget your order of operation. And then as a strategy for working with surds when you've got them as fractions, probably a good idea to try and simplify the numerator, simplify the denominator, and then see if we can cancel anything down at the end.